Okay, so I want to show you how to complete some of these acceleration practice problems. If you see on your worksheet, this would be pretty much the same one that you have. Here's the equation, right? So acceleration is final speed minus beginning speed divided by time. The general equation for that is A equals V2, or this could be V of F, but V final minus V initial divided by time. And you'll see at this V2, that's really V of F, V final minus velocity initial. Okay, and then when you do a problem, you just have to figure out what each one of these are, and you can solve it. Also, you want to remember that you can move things around on here, and you could figure out what another, not necessarily do acceleration, but you could figure out v of 2, or you could do time, or you could even figure out v of I as well. Okay, so and here are these other equations down here. Again, remember v of 2 is v of f, and then this kind of gives you two other examples. If you want to make an index card and have that ready whenever you do this, that's fine with me too. Definitely encourage you to practice these. Usually the hardest part is figuring out what is v of f and what is v of I. So if we look at one of these problems here, I'm not going to look too detailed, but I'm going to do these for you. I'll do one of them with you, and then I will do the rest, but you don't necessarily have to watch the video. But if you want to not sure how to do it, you can then skip the video or watch each solution. That's fine with me too, but whatever works for you. But I figured I'd give you the option to see what the right answer is. Okay, so this one right here, it says a skater increases her velocity from 2 meters per second to 10 meters per second in 3 seconds. So what is this skater's acceleration? Again, this is the equation. A equals V of V2 minus V of I, or VF minus V of I, divided by time. So we have to figure out what each one of these things are. I usually like to just do it right in the problem. So a skater increases her velocity from, so this is V of I, right here, because it's from, it starts there. Okay, 2, so this is V of F, the final speed, and then this is the time. Right, so we have those three things, this, and this. And then you just plug it into the equation. So this is going to be VF, that's 10, V of I, which is 2, the time is 3, and you do all the calculations. 10 minus 2 is 18, divided by 3 is going to give you 2.7 meters per second squared. And remember, acceleration is squared, because you have a time down here, and you also have meters per second up the top. So, and the end of it comes meters per second squared. So that's kind of the introduction to it. Let me give you one more problem, and then you'll be ready to try this on your own. You can check your answers, because I will solve each one for you and explain it. Okay, so here we have our first problem. It says, while traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. What is the automobile's acceleration? Okay, and it says, remember that the negative value indicates a slowing down or deceleration. You can just leave it negative. Okay, so we have this. So from, this is V of I, that's where it starts, to, this is V of F, or V of 1, and this is 12 seconds time. So then we write the equation. A is V of F minus V of I divided by time. Then we plug it in. V of F is 15. V of I is 24. And then time is going to be 12 seconds. And then you just do it's going to be negative 9 divided by 12, and that's going to give you negative 0.75 meters per second squared. So that's the first one. And you just want to remember, you need the negative sign here because it shows it's slowing down, and that should give you your answer. So if you want to go ahead and try the rest of them and come back and see how you do, that's fine. But I'm going to solve the rest of them for you so you can see how they're solved. So next one says, a parachute on a racing dragster opens and changes the speed of the car from 85 meters per second, that's our initial, from, to, this is 45, that's final, in a period of 4.5 seconds, that's our time. I would like to repeat this equation. A, V final, V initial, divided by time. So then we have V final, 45, minus V initial, 85, divided by time, which is 4.5 seconds. So then we do this. This is going to be 40, negative 40 over 4.5. And we use our calculator here. Let me do this off to the side here. And then we just do 40 divided by 4.5, 8.8, so equals negative 8.9 meters per second squared, because that's going to be an acceleration of meters per second squared. That's 2. We keep going. We then have a car traveling at a speed of 30 meters per second. That's v of I. That's where we start. Encounters an emergency and comes to a complete stop. So it doesn't give you a number, but we know velocity final is 0. How much time will it take for the car to stop? That's t. Does it give us the t? If it decelerates, this is our a. So now we have a different one. So this is going to be a equals v of f minus v of I divided by t. But we don't have a. We have a, and we want to solve for t. So then what we have to do is we have to switch these. So we would just use some algebra, and in the end we'll get t equals v of f minus v of I divided by acceleration. Okay, so then velocity final is 0 because it comes to a complete stop, minus 30, that's the initial, meters per second, divided by the acceleration, which is negative 4.0 meters per second. We then do the math. It is 30 divided by 4.0, that gives us 7.5. And then since we're dividing a negative by another negative, we get a positive, and that's 7.5 seconds. So that's 3. Okay, we keep going. We're going to read this down here. Okay, so then it says if a car can go from 0 to 60 miles per hour, and actually we're going to skip this one. Don't worry about this one. We're going to skip this. I'm not going to worry about that. Okay, we're going to do 5. It says a cart rolling down an incline for 5 seconds, that's our time, has an acceleration of this, that's a. If the cart has a beginning speed, that's v of I, what is its final speed? V of f. This is the one we're trying to figure out. What is its final speed? So we then first look at the equation. A equals v of f minus v of I divided by time. Okay, what I like to do is I like to plug the numbers in. So acceleration of 4. I'm not worry about the 0.0 right now. Velocity final, we don't know. It's minus velocity initial, which is 2. And then the time is going to be 5 seconds. Okay, so now we know we can then take this 5 and multiply it by 4. That's going to be our algebra, 20. Because we're going to multiply both sides by 5. We're just using algebra. That is then gone. That will then give us 20 equals v of f minus 2. Then we just have to add 2 to both sides. And that gives us 22 equals v of f. So 22 meters per second is our velocity final. Right? And we could even plug it in and see if it was 22, 22 minus 2 is 20, divided by 5 is 4 meters per second squared. So that's right. That's the answer. Then we look at 6. It says a helicopter speed increases from 25, that's our v of I, to 60, v of f, in 5 seconds time. What is the acceleration? It's a pretty easy one. We've done these. Okay, divided by time. Then we're just going to do v of f, 60 minus 25, right, v of I, in 5 seconds. So we get 30. 60 minus 25 is 35. Divided by 5 is 7 meters per second squared. That's our answer. And the last one, 7. I think we have a couple more there. We did. So 7, it says, as she climbs a hill, a cyclist slows down from v of I to this. And look, we're going to, actually, don't worry about this one. It's miles per hour. And I'll take these off of your worksheet. Kind of borrow these from other people. I'm not going to have you convert them. Okay. All right. So here's the next one. This is 8. This is a motorcycle traveling at 25 meters per second accelerates at a rate of, okay, it's traveling, this is v of I, accelerates, this is acceleration, this is time, 6 seconds. What is the final speed? V of f, okay, for the motorcycle. So we go A, v of f minus v of I divided by time. Acceleration is 7. V of f we don't know. We don't want to know what that is. Minus v of I is 25. And then the time is 6 seconds. So then we're going to move this 6, do the math, through the problem first. So we multiply both sides by 6. To remove the 6 to the other side, it's 42 equals v of f minus 25. We're going to add 25 to both sides. That gives us 67 equals v of f, 67 meters per second. Then if we just did it, 67 minus 25 divided by 6, that'll give us 7. So that's correct. Next one. So then it says a car starting from rest, v of I is 0, accelerates right there. What is the final speed, v of f, at the end of 4 seconds time? So then A, v of f minus v of I divided by time. So it wants to know, so acceleration is 8, v of f, we don't know, v of I is 0, because it starts at rest, and then the time is 4 seconds. Okay? So then we just take 4, multiply 4 by both sides, 32 equals v of f minus 0. We don't worry about that, it's just 32 meters per second is velocity final. Okay, let's keep going. A couple more. Okay, after traveling for 6 seconds, a runner reaches the speed, so this is our time, right? Runner reaches speed, its velocity final. What is the runner's acceleration? A. So then it doesn't really give us a speed, but we have to kind of assume that it's starting from rest. Okay. So then we're going to say A, v of f minus v of I time. Okay. So I'll let that phone going off. So acceleration, we want to know that. So v of f is 10 minus 0 divided by 6 seconds. Okay. So then we do our math. Get my calculator there. So then it's going to be 10 divided by 6. It's going to be 1.7 meters per second squared. This can be hard sometimes because they kind of trick you, but just realize this is, you have to get some kind of starting speed. If you don't know what it is, you almost have to assume it's starting from rest. Okay? All right. So now we have a cyclist accelerates at a rate. So this is our acceleration. How long? Time. This is what we don't know. Will take the cyclist to reach a speed of. This is velocity final. Okay? And then again, velocity initial. You have to just assume it is 0 because it could be anything then if it's not, and we can't figure out the problem. So then again, acceleration, velocity final, velocity initial divided by time, and we figure it out. So the 7 is acceleration. How long? We just know the time, right? And then reaches the speed. That's velocity final 18 minus 0. So then we're going to switch these. We're going to use algebra. We're going to multiply both sides by t and then divide by 7. This then becomes t equals 18 minus 0, which is 18, divided by 7. If we then do our math, we do 18 divided by 7, that gives us 2.6 seconds. Okay, and then last one, a skateboarder traveling at 7 meters per second. Get that straight. That's acceleration. Rolls to a stop. So velocity final is 0 at the top of a ramp in 3 seconds time. What is the skateboarder's acceleration? So it says traveling at 7 meters per second. That's velocity initial, right? And velocity final is 0. I misspoke that. So it should be acceleration, velocity final, velocity initial divided by time. So then you get velocity final is 0 minus the 7, which is velocity initial, and then it's 3 seconds. So then we just do -7 divided by 3. Let me do this. 2.3 meters per second squared, and it's negative. That's how you do them all. Hopefully you got these done. We'll review them in class, see if you have any questions with them, and I'll see you soon.